perimeters of our solar system, dwarf planets made of rock and ice. But one planet remains an enduring mystery for even the most advanced telescopes: Saturn and its enigmatic rings. Galileo was the first to see that this planet was different from the rest. For him, the strange features he observed looked like ears. He presumed they were moons. Later astronomers saw them as a vast flat ring encircling the planet. Then, one man discovered that this ring was in fact made up of several concentric rings. That man was astronomer Giovanni Cassini. Now, a mission named after him is investigating why Saturn has rings at all and what they're made of. NASA's Cassini mission.
3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
In the nose cone of this rocket is the space probe Cassini. Ahead is a 2 billion-mile journey to the planet Saturn. On board the probe are sophisticated telescopes. They will investigate Saturn's mysterious rings by traveling as close to them as possible.
Good solid rocket booster separation. First stage
Item
ignition.
152.
As Cassini heads for Saturn, the furthest planet in Galileo's solar system, it uses the massive gravitational pull of Jupiter as a boost to slingshot it out millions of miles towards its destination.
In the world of telescopes, Cassini has some of the fastest moving telescopes in the solar system, going by at Jupiter at something like 70,000 miles per hour.
Even at such tremendous speeds, the journey still takes 7 years. But finally, Cassini approaches Saturn, 934 million miles from Earth. It dives through Saturn's outer rings to enter orbit around the planet. These are some of the images Cassini takes of the rings. They may look solid, but they are made up of billions of chunks of ice and rock, ranging in size from a grain of sand to the size of a house. And they are spread over hundreds of thousands of miles. But where is all this stuff coming from? Cassini's telescopes reveal that the inner rings are made up of material blasted off the surfaces of Saturn's moons by meteorites. But the furthest visible ring from Saturn is still a mystery. This image taken by Cassini shows that unlike the innermost rings, the outermost ring is a ghostly mist of microscopic particles. Astronomers suspect that the icy moon Enceladus could be where the mist is coming from. But until now, no one has been able to work out how. Then, Cassini's telescopes see something never observed before. Vast plumes of vapor streaming from fissures in the surface of Enceladus.
These plumes go up hundreds of kilometers. That's pretty exciting to find erupting out of an icy moon.
Could these plumes be the source of the outer ring? To find out, Cassini's telescopes do something extraordinary. They fly through the plumes and taste the vapor with onboard detectors.
That's a spectacular thing to be able to do, to be able to tap the interior of an icy satellite.
Back at Mission Control, astronomers analyze the data streaming in. The vapor pouring out of Enceladus is made up of ice, salt, and ammonia. It is exactly the same material as the outer ring. It can only mean one thing. Enceladus's plumes are the source of the misty ring. This is a major discovery. Cassini's space-borne telescopes are solving the mystery of Saturn's rings that has plagued astronomers for centuries. Telescopes today are journeying deeper into space and searching further to discover secrets that Galileo could never have imagined. But to capture pristine images like these, telescopes had to undergo a dramatic evolution. Back in the 1650s, the first step in this evolution was going to great lengths, quite literally.
Telescopes became very long, 15, 20 feet.
The problem with early telescopes was fuzzy images. The reason? The shape of the lens. As NASA astrophysicist Kim Weaver demonstrates, when a strongly curved lens bends or refracts beams of light, the light doesn't all come to a single point.
First of all, the different beams of light don't line up, and so the image that you get with this lens would be really fuzzy. Also, some of the light has its colors split out, and that distorts the image.
The only way to minimize the blurriness and the rainbow colors is to use thinner lenses with a shallower curve. Because the light comes to a focus further from the lens, refracting telescopes get longer and get greater magnification. 17th century astronomers make ever thinner lenses and space them further apart.
By about 1660, telescopes have magnified 50 or 100 times, and those lengths increased and increased and increased.
This is the first space race. On the quest to see ever further, telescopes reach absurd proportions, up to 150 feet in length, half the length of a football field. These unwieldy telescopes are better, but astronomers want to see even more detail, and these telescopes don't eliminate the rainbow colors altogether. Then, one of science's greatest minds sets out to solve the problem: Isaac Newton.